Okay, welcome back. I am also started recording. We have only 5 with me, 5. Anyway, let me just start, continue from friend class, which I started in our previous lecture. Sorry. Okay, so like the friend functions, we can create friend classes. So still by using friend keyword in front of a class prototype, we can make it a friend class. So when we declare it inside of another class, it is becoming a friend class, and it is becoming a friend of the class that defined inside. Okay. So this is the last example of friend classes and friend function topic. So we in the program we declare an object object B from class B class. So class B is here. And when we create the object, num_b value will initialize to 1. Okay. So inside class A, we declare the class B as friend. So what does this mean? From class B, I can reach the private parts, or if we have protected parts as well. Okay, so here in cout, it is saying sum and object B add. So we are doing what? We will make a function call to add function in object B, which is created from class B. So add function is where? Here. And this time it is inside. It is not a friend function. Actually, all functions are becoming friend function when we are just declaring a class, friend class inside another class. Anyway, so because of it is feature is a kind of friend function, here we created an object from class A. So when we created an object, again, if we have a constructor, it will be executed. So num a will be 12. And it is return object a dot num a. So we can directly reach the num a inside object a, which num a is a private number. But how I can do it like this one? Because I declared class B as a friend of class A. Okay, and plus num b is here, so we don't need to just do anything else. So by this way, I can just add these two numbers. One of them is in other class, one of them is in same class by using friend class feature. Okay, so this is the way of using friend classes. Okay, I hope it is not confusing for you. By the way, this codes I may ask like trace questions, or I may ask, I can show you the program and ask just specific things. So I am not going to ask this kind of complicated coding, in the exam. So if you are able to trace and find the result, most probably I will ask this kind of questions in the final. For friend functions, friend classes topic. Okay, so the output will be the addition of two values, and it is 13 again. So this is the friend function and friend class topic. Last time I just gave one example, but it was not enough. That's why I added some examples. I'm going to upload this slide to Moodle as well. Okay, I explained everything here. So I have one more topic that I will not do one more lecture today. 3 hours is more than enough. So I will start to polymorphism, and the point that I stopped, I will continue in our last lecture. As I told you, I have a few things left. I want to at least show you what are they, because maybe later you will need to use object-oriented programming. In C++, if you learn these concepts in C++, it will be much more easy to use them by using Java, for example. But if you just directly try to understand them by using Java, it will be harder to understand, because it is a little bit complicated than C++. So I want to show all of them. That's why I prepared the slides to make, these slides, I didn't do it before, because in object-oriented programming, lecture, normally we were starting either from the beginning of the C++ programming language, or just we try to show functions, I mean pointers, arrays maybe, so some basic topics that you need in object-oriented programming. But this semester I directly start. That's why we have time to see everything. Okay. The other topic is polymorphism. So in polymorphism, I will cover 4 or 5 different topics. So I mean overloading, overriding, virtual functions. So I'm preparing these slides. Of course, I'm not going to finish it today. So I am preparing these slides just to combine all of them together. So we will not see it later. Okay, we already started, but I remember that the slides also not good. So I just prepared from zero. Okay. Actually, polymorphism. One second. Polymorphism means many forms. So we can say that to make an action in different ways. In polymorphism, when we are using overriding, I will explain what it is. We are using inheritance. So in most of the parts of polymorphism, we are actually have inheritance. That's why I started to just try to explain the difference between polymorphism and the inheritance. So you know what is inheritance? It is letting us inheritance feature, letting us inherit attributes and methods from another classes. And polymorphism uses those methods to perform different tasks. And also it is allowing us to perform a single action in different ways. So maybe same function name in base class and the derived classes, but each of them are doing different things, and according to our needs, we can use the base class or derived class. So inheritance allows code reusability, and the polymorphism is the occurrence of one function with different form. So as I told you in previous slide. And we can say that inheritance is implemented on the classes because we are inheriting classes. But polymorphism is implemented on methods or functions. Methods, we can say, or function, it doesn't matter. Same thing for C++. As inheritance allows a derived class to use the elements and methods defined in the base class, the derived class does not need to define those elements. So if we have some elements in base class, we don't need to do it in derived class as well. That's why we save code or so this increases the code reusability and reduces the length of the code in inheritance. On the other hand, polymorphism makes it possible for an object to decide what form of the method it wants to invoke at both compile time and runtime. So we are able to decide which one we need to run. I mean, in base class, in derived class. Okay.
Hello, sir.
Yes.
You are not seeing what you are talking about. You are just seeing the slide you finished.
Sorry.
You are not seeing the slide you are talking about right now.
Really? I just
Nah.
sharing it. Everyone is like that.
Let me send what I'm seeing right now on my
Okay.
screen.
Okay. I'm going to just share again.
It's okay now.
Okay, but, is it okay now?
Yes.
Which slide you are seeing? Polymorphism title.
Polymorphism in many forms.
Okay. Okay.
And
So you just listen what I am saying. Anyway, so I just make an introduction so you can also check. I just try to express the difference between inheritance and also the relationship between inheritance and the polymorphism. Okay, so polymorphism means many forms, and it occurs when we have many classes that are related to each other by inheritance. So we discussed this before. Also this slide, but let me to just fastly pass it. We have two types of polymorphism in C++, compile time and runtime polymorphism. In compile time, we have function overloading and operator overloading. And in runtime, we have virtual functions. So in compile time polymorphism, a function is called at the time of program compilation. So while the program is compiling, at that time it is called. Let me show. And we call this type of polymorphism as early binding or static binding. And function overloading and operating overloading is the type of compile time polymorphism. Okay, in compile time polymorphism, we can start from function overloading. So here the point is the function return types is not important. I mean, they can be same, different, doesn't matter. So this is not just is a kind of acceptance of function overloading. How we can do function overloading? So the number of arguments or data types of the arguments should be different. And of course, the name of the function should be same. So same function name, but number of arguments or data type of arguments should be different. So the overloaded functions are involved by matching the type and number of arguments. So this information is available at the compile time. That's why we are saying compile time polymorphism. And therefore, compiler selects the appropriate function at the compile time. So according to the function call, compiler will select the appropriate one. Okay. You can have multiple definitions for the same function name in the same scope. Of course, the definition of the function must differ from each other by the types and the number of arguments in the argument list. So each function name will be same, but the definitions should be different to make sense, or at least the arguments or number of arguments, data type of arguments or number of arguments. And you cannot overload function declarations that differ only by return type. What does this mean? Let me to go back. I mean, if you write something like that, let me to write another test function. Let's say float test and okay. So this is if we have this four functions, I can't write this one as the fifth one because this is completely same, just the return types is different. But rule saying us you can't make a function overloading by checking the return type. So if you do something like that, this will give an error. I just try to explain the sentence given in the next slide. This one. Okay. And notice that the return types of all these four functions are not the same. So return types are not the same. Overloaded functions may or may not have different return types, but they must have different arguments. So the rule is here. So this one is not correct as well. So you have to say, if you say just instead of this is also same number of arguments and same data type. Return type is different, but this is not just enough for overloading. But you can do something like that to overload this one. You can make double test, and here you can say, for example, double B. If you make it like that, now it can be overloading. Okay. Okay. We discussed this example in the class. Here, just let me to just show you something. In this one, here, this is just when you declare it like this, it is like a string. Okay, but here our point is we discussed it in the lecture. Think about that when you make a function call with a parameter of integer, it will execute this function. When you make a function call with a parameter value is double, it will execute this one because their names are same. And if you just make a function call to a string, it will execute this one. So according to the data type, arguments data type, it will execute different functions. So this is function overloading. This is the output. We know what is the output. Let's continue. Okay. Okay. So here, we have two different function calls. One of them is the parameter is -5. An integer, as you know, integer can take negative values. Then the other one is 5.5 float. So when you call this absolute minus 5, it will go to absolute integer a function with integer type parameter, and it says it is just it is trying to just show us the absolute value. I mean, when you enter a negative, absolute value always gives positive values. So if you give a negative value, it will also give its positive value. So it makes a simple if here. If var value is less than 0, it will just make minus var, assign the minus var value to var. What does this mean? Here, var value is minus 5. So it is less than 0. So if it is less than 0, it will make minus var. What is var value here? Minus 5. So minus 5 will be positive value. So it will put the positive value here. Otherwise, if it is like this, it will execute this one. As you know, if statement or loops, if you don't write a begin end, it will just consider only the first line. So this if statement is something like that. So if this one is not succeeded, means var value is either 0 or a positive value. So it will continue to execute from this one. Otherwise, this one. So if absolute value here is 5, it is not minus 5 and it is 5, it will do what? It will come to here. When it is checking this, it will not enter the if statement because it is 5. So it will directly return var. So this one is according to the data type, it will write the absolute value. So in the second one, it is again same, but it will execute by the different function. Again, absolute function, but with float variable, because this one is float. So same operation, but it is using float type. So this is function overloading. So here it is explaining how it is, which one is, when it is minus 5, it is executing the this function, and when it is 5.5, I mean float variable, float value, it is executing this one. Okay, let me to just explain this example and finish our lecture. Okay, this one overloading using different number of parameters. So this time data type is same, but number of parameters are different. So here a call function with integer type parameter, call function with double type parameter, and call function with two parameters. Okay, so we declare two variables, integer and double, integer a double b, and we call same function name but with different data types and parameters. So when you call display a, it is integer, so it will execute this one. When you call display b, it is double, so it will execute this one. And when you call display AB, it is with two parameters, so it will execute this one. So two ways of function overloading. It is either by a different number of parameters and or different data types of parameters. Okay, it is an easy concept, function overloading, but you just need a little bit to be a little bit careful. It is explaining, and I will continue from runtime polymorphism. Actually, we have operator overloading here. I don't know, maybe I will put or not to the lecture notes. I didn't decide yet. Most probably, I will just finish it and don't put it. Okay, we can stop here. It was a very silent lecture, but I feel better when I think that I recorded everything, and you can, when you need to learn, you will come back to recording and watch it. Okay, we have only 1 minute, so we can finish our lecture. Thank you for attending, and have a nice weekend. See you next week.
Jokes out.
Thank you, Dr. Umut. Thank you very much.
Not at all. Not at all. You.
You are the best teacher. You are the best teacher, sir.
Yes.
But hope the exam will not be difficult.
Sorry.
We are approaching the exam, sir. So maybe area of concentration, maybe yeah.
Oh, your voice is coming very bad because of the microphone, maybe.
Sorry, sir.